All right, let's go on to lecture 8. And in lecture 8, this is part B. Part B, there's only two parts to this lecture, so this is the second and last part. And in this part, you might remember part A, we're talking all about the periodic table. What the heck is the periodic table? What do you call the different parts of it and all that? In this lecture, well, we're not talking about the periodic table, at least not too much. We're back to something we talked about previously. So let me flip the slide here and all right, let's go back to something we talked about in a previous lecture. All right, so in a previous lecture, we were worried about how many like protons and neutrons and stuff were in an atom. So one thing we didn't bring up in that previous lecture, I never really talked about electrons, did I? So that's what we're going to get into right now. And there's also two terms that are going to be important. We're going to be learning the difference between an atom, A-T-O-M, and an ion. So what's the difference between an atom and an ion? Now to start off with, let me just tell you the difference. In an atom, if you hear the word atom, if I ever say atom, atom means that we have something where they have the same number of protons and electrons. So the number of protons and electrons are the same. Now, in an ion, that's not true. In an ion, we'll say they have an unequal amount. Oops, I miswrote that. Uh-oh, I gotta erase that. Sorry. Unequal amount of protons and electrons. So the electrons and protons, that's an and symbol there. They're not the same. All right, so how am I going to tell you the amounts of anything? Well, the way we did that was we learned about this thing called atomic notation. So let's get back to that for a few minutes here. So for atomic notation, I might have written something like this, 4120 Ca. Do you remember what all that stuff was? Oh yeah, this is the symbol, so I'm thinking of a calcium atom. And then the numbers, just to remind you, this bottom number is the number of protons, shoot, again, my spacing is a little off here. Let me rewrite that. So that's the number of, I'll just write protons, that'll save me a little room. That's the number of protons. And then the top number, just to remind you, that was the protons plus the neutrons. All right, so the bottom number, by the way, oh, that had a name. Do you remember what that bottom number was called? That was called the atomic number. And the top number was called the mass number. All right, so what we could do with that symbol was I could tell you a little bit about what's inside of this atom. So the bottom number, there's your protons, 20. And then how do we find the neutrons? Do you remember? We subtracted. 41 minus 20, this fella has 21 neutrons. Now, that's as far as we got with this topic before. So right now, though, I'm going to bring up electrons. And the key to knowing the number of electrons is what I just wrote up here at the top. In an atom, which is what I have right now, in an atom, the number of protons and electrons are the same. So if this fella has 20 protons, he's got 20 electrons. All right, they're going to be the same number. So an atom, A-T-O-M, and an atom, the protons and electrons are the same. Now, in an ion, that's not true. So there are particles out there in the world where that is not the case. Let me show you a symbol for an ion. So the symbol for an ion, it might look something like this. 4120 Ca plus 2. So one way I know right away that there is an ion, that this is an ion, is that if there's an ion, you're going to see a charge in the corner. The charge will be in the top corner, top right corner. If there's nothing up there, it's like neutral, it has a charge of 0, that's an atom. But if there's a charge up there, then it's an ion. All right, so let's go through and figure out what the heck is in this ion though. So the bottom number again, hey, that's still your protons. That means it's 20. The top number again, that's your protons and your neutrons. So that means if I subtract, yeah, I got 21 neutrons. But the electrons are different now. Before, the electrons were 20, the same as the protons, but not now, not in this topic. So in this case, if the protons and electrons are unequal, that means they're not going to be 20 electrons this time. And the way we can figure that out, it's kind of like, just adding up some numbers. I know that the total between the two is going to add up to +2. That tells me I have 2 extra pluses. That's what that means. So there are not 20 electrons. There are not 20 electrons. I would have, instead of 20 electrons, I would only have 18 electrons. Does that work? I think it does. If you have 18 negatives, and you got 20 positives, you put it together, the total is I have 2 extra positives. And that's what it's supposed to be. There's 2 extra positives. All right, with that, we're going to do a couple more of these, all right? So an ion just means I got a charge. An ion means that protons and electrons are not identical. And you can figure out the amounts taken into account that charge. All right, so let's move on to another couple examples. Let me flip the page here. All right, let me put up two more. Let's look at 2 more examples here. All right, so another one. All right, let's see, you saw this thing in the world. 23 and 11 Na plus. What the heck is that? So what I really want to know based on that is I want to be able to figure out, how many protons are in this thing, how many neutrons, how many electrons. That's kind of what we're going to get based out of that symbol. Now, while we're at it, I'm going to show you one more. All right, one more. How about if I had 17, 8, 0, and then 2 minus in the corner? All right. So again, based on that symbol, I want to figure out how many protons, neutrons, and electrons are in this thing. All right, a couple things I want to point out to you. Point number 1 is that both of these things are ions. I know that because I see a charge. Now, if we look at the example on the left, it just says plus. Sometimes we do that. If it just says plus, it really means that it has a positive or a 1 charge. So if there's no number, it's a 1. Man, we do that a lot, don't we? Always, if there's no number, it's a 1. All right, now the other thing I'd point out to you is usually we write 1 plus. So this thing's got a positive charge. The oxygen example has a 2 minus charge, so it's got a -2 charge. All right, so with that, let's go through them. So let's start off with the Na on the left-hand side. Oh, anybody remember what the Na is? Na is sodium, right? It's sodium. So in this sodium ion, there are 11 protons. Remember, the bottom number is your protons. That should match up, by the way, right? Because if you're sodium, I don't care if you're a sodium atom or ion, you have 11 protons. Remember how we talked about how that goes together with a symbol? All right, now the top number is your protons and your neutrons together. All right, so if I want to know just the neutrons, how many neutrons does this thing have? What would I do? I need to subtract, don't I? So this thing has 12 neutrons. All right. Now the newest thing to you is the electrons. The number of electrons will not be 11. It will not be the same as the protons because this is an ion. So if I want to know how many electrons there are, let's see, what am I told here? I'm told I have an extra positive. That's what that means. I have an extra positive. So if you have an extra positive, you only have 10 electrons. Does that work? I think so. 10 negatives. 10 negatives, 11 positives should add up to -1. So together, they should make sense with that top number, that charge you see there. All right? All right. Let's try one more. All right. Let's go to the oxygen example, the one on the right there. Now, on the right, again, I see that bottom number. Oh, just like before, that bottom number in the bottom left corner, that's your protons. There's 8 of them. All right. If I want to know my neutrons, what do? Oh, I subtract, don't I? So this is protons and neutrons. So if I subtract, I get my neutrons. That would turn out to be 9, I suppose, right? And then now my electrons. Now this one, gotta be a little careful. The electrons will not be 8. When I put my protons and electrons together, it should match up with -2, right? It's supposed to add up to -2. So what do you have more of this time? What do you have? Extra protons or extra electrons? You must have to have, if you want -2, you have 2 extra electrons. So you'd have 2 extra electrons. So this would be 10. Oh, well, whatever. Does the color matter? Maybe not. 10. You would have 10 electrons. So when you're done, you can always kind of think it through. Does it work? 10 negatives, only 8 positives. I have 2 extra negatives. That works. It's supposed to be 2 extra negatives. All right, there's one other little thing I want to tell you. Man, you know, there's vocabulary for everything, all right? So we've already mentioned that both of these would be ions, right? Because they both have a charge. But you notice in these examples, they could be a positive charge or a negative charge. And so there's a term for that. If you have a negative charge, let me flip to another color maybe. Ions with a negative charge, ions with, oops, that's a T there, with a negative charge are called anions. All right. And then ions with a positive charge, ions with a positive charge, like the sodium. You know what? I kind of did these backwards, didn't I? Well, whatever. All right, well, you get the idea. This guy, oh man, I'm sorry. So this is an anion, right? He's got a negative charge. So that would be the oxygen. I kind of flipped them. Oops. All right, an ion with a positive charge would be a cation. And in this example, that's the sodium. Oh, they're sort of backwards from above, but if you got this, you're okay, right? Anybody with a negative charge, you're an anion. That's the oxygen. Anybody with a positive charge, you're the cation. That would be the sodium example. Kind of flipped them on you there. Well, bad teacher. What can I do? Make mistakes, don't we? All right, so with that, oh, let's try one last one. Let's try one last one. So let me put up one. I'll give you a chance to think about it. All right, let's go on to another example here. And let's see. I got to flip the page again. I made a mess out of this one, didn't I? All right. All right, let's try one last one. One last one. So what if you saw this guy right here? 3115p 3 minus. Tell me all about this ion. Got a charge. How many protons? How many neutrons? How many electrons? I want you to try this one. I want you to think about it. Let's confirm that it's making sense. I don't know. Is it making sense? I hope it is. Oh, gosh, I really hope it is. All right. How many protons are there? How many protons are there? Look at that symbol. How many protons are there? The number in the bottom corner is your protons. This thing has 15 protons. Okay. How many neutrons are there? How many neutrons are there? Okay. The number in the top corner, to remind you, is your protons and your neutrons. So you always subtract to get your neutrons. Should be 16. How many electrons are there? How many electrons are there? Okay, in this case, the number of electrons, it would have to be 18. 18 works, doesn't it? I hope, because 18 negatives, 15 positives, you put it together, there should be an extra 3 negatives. That's what that number up there was telling me. There's an extra 3 negatives. So having 18 electrons would make sense as far as going with that charge. Okay? All right, one last question. Is this an anion or is this a cation? Is this an anion or a cation? It is a cation because it has a negative charge. I gave you somebody with a negative charge. All right, with that, let's just do a couple more little quick examples. Let's see if we can figure out a couple more. All right, let me stop here and move to the next slide, I should say. Okay, I want to show you just a couple more quick examples, slightly different, just to get a little variety here. So first thing I want to point out to you, this is a periodic table. It's slightly different than the one I've been using just because I wanted you to be able to read a little better. A couple things that might help you out, kind of not a little tangent, but the yellow guys, again, some people were asking me, those are the main group elements, and then the blue guys, those are the transition metals. So when we talked about the parts of the periodic table in part A, if you had a little trouble telling the difference, that's the main group or all the yellow ones, like these guys, and then these guys are the main group elements. And then the ones in the middle, those are the transition elements. Some people were a little confused on that. All right, I think I'll point out to you, this one, you just see the symbols, and then you see that number above the symbol. Just to remind you, the number above the symbol on the periodic table, just like in the one you're normally using, that whole number, 1, 2, 3, 4, 5, 6, that's the atomic number. Another way of saying that is that number is the number of protons, right? That's called the atomic number. Like for carbon, it's a 6. All right, with that little hint, let's get started on my little question. What is the symbol for an ion who's got 12 protons and only 10 electrons? So if you've got 12 protons, anybody with 12 protons, I don't care if you're an atom, an ion, I don't care what you are. If you got 12 protons, what kind of atom are you? What is your symbol? 12 protons, you are magnesium. All right. So honestly, this almost made the answer too easy, right? It's got to be C. C is the only one of these options with 12 protons. It's magnesium. All right, now let's just confirm, because it says +2 there. Are we sure about that? I think so. So if you got 12 protons and you only got 10 electrons, what's your overall charge? What's your what's the net? What's the total together? Oh, there's 2 extra positives. That's why we're seeing that +2 right there. Oh, I just dropped my pen. All right, so that's why we're seeing that +2 right there. Now you notice they didn't. I gotta grab my pen. Oy, everything's coming apart on me right here. You notice that they didn't put the mass number and atomic number on the left. That's okay. They're just kind of simplifying it a little bit for you in this question. All right, so magnesium with a +2 charge, that matches up with somebody with 12 protons and only 10 electrons. All right, one final example. Let's do one last one. All right, for this one, I give you another symbol. And again, it's sort of been a little simplified. And I want you to tell me, based on this symbol, what's inside of this fella? How many protons, electrons, and neutrons? That should tell you right away, is this thing an atom or an ion? It's an ion. How do you know it's an ion? Because it's got a charge. That's how you know it's an ion, right? It says, I'm going to write it down here just so I can refer to it a little better. I need a little more room. All right. It's an ion. It's got a +3 charge. That makes it an ion. It says it. All right. If it doesn't say anything, it's an atom. But if there's a charge there, you're an ion. All right, now there's one other thing that might help us. They want me to figure out the electrons, the protons, and the neutrons. Let me remind you, this number in the top corner is your protons and your neutrons. Normally, there's a number in the bottom corner that you're used to being told. This time, this question is a little meaner to you because it doesn't say that number there. But what is that number down there again usually? That number is the number of protons. It's the number of protons. And is there any way to know that number? Because they didn't write it. I got to know it. Oh, if you're iron, you've got 26 protons. So even though they didn't write 26 there, you can figure that out. You can figure that out because if I tell you iron, Mr. Iron, iron atom, iron ion, doesn't matter. 26 is your protons. All right, so the bottom number is 26. The bottom number is 26, the atomic number. There we go. Blah, kind of hard to get it out sometimes. All right, so with that little background, let's see if we can actually answer the question. All right, how many electrons, protons, and neutrons are in this thing? All right, let's just go ahead and figure it out. Okay, the bottom number, the protons, is 26. There are 26 protons. If I subtract, what do I get? 56 minus 26? Well, you get 30, don't you? And what is 30? That's the number of neutrons when you subtract. And then how about your electrons? 23 or 29? How many electrons are there? 23 or 29? There would be, let's see, there's 3 extra positives. Oh yeah, that's what that means. There's 3 extra positives. So there's only 23 electrons. There should be 23 electrons. All right, so you have 3 extra pluses. So that thing, that iron ion, I guess, that ion, it's kind of hard to say, iron ion, that has 23 electrons, 26 protons, and 30 neutrons. That goes along with, I guess the right answer would be A. They're listed in the same order I wrote them. Electrons, yeah, 20. Yeah, that's right. All right, so that's it for lecture 8. Hey, we only had 2 parts to it. They were a little long, so hopefully I made them through it. And if you have any issues, of course, contact me. That's why I'm here. You can email me or whatever. I'll get back to you as soon as I can. So I hope you're having a good day out there in chemistry land, and I'll see you again soon. Hey, one more thing. I just filmed a demo outside with my wife, and she actually asked a really good question in the end. Did you hear it? She said, "Well, why is it that you put sodium in water and it blew up, but then I eat sodium chloride, salt, and it doesn't blow up in my mouth?" Well, what's the difference? Well, the difference is sodium. The sodium I was using outside was the atom sodium. All right, it's the metal sodium, the element sodium. All right. Now, when you go home and you eat salt, you are eating sodium chloride, and sodium chloride contains the ion sodium, Na+1. So that ion and that atom, they're not the same thing. So one is really reactive. You saw it kind of blew up in the water, or gave off a gas at least. But then sodium, when you eat sodium or potassium, it doesn't hurt you because you're actually eating the ion version. Potassium's the same thing, right, from a banana. You're eating potassium ions in a banana, not the metal potassium. So atoms often are really reactive, and maybe the ion version is not reactive. So that's what's going on there. All right.